Assalamualaikum and hi everyone. Welcome to our video presentation. Subject MAT 183 Calculus 1. The title is Technique of Differentiation.
Hi everyone, so today we are going to explain to you about differentiation. Before we start, let me explain what differentiation actually means. In calculus, differentiation is the operation of finding the derivative of a function, which quantifies how a dependent variable changes relative to an independent variable. Visually, this evaluates to the precise slope of a curve at a given point. In the differentiation, we have 8 basic differentiation rules, which is number 1 is the constant rule, second we have the constant multiple rule, third we have power rule, fourth we have sum rule, 5 we have difference rule, 6 we have product rule, 7 we have quotient rule, and the last one we have chain rule. As you can see, this is the basic derivative of standard function.
Okay, now I will explain to you for question 2, which is find dy over dx for the following function. There's two questions, a and b. For a, y equal to tan 1 minus x times ln x square. So first we identify the function, which is u equal to tan 1 minus x, v equal to ln x square. So then for step 2, we differentiate each part, and u equal to tan 1 minus s becomes negative sec square 1 minus x, and for the v ln x square, differentiate it and it becomes 2 over x. Then we apply the product rule. The formula is dy over dx u times v prime plus v times u prime. Then we substitute, so tan 1 minus x times 2 over x plus ln x square times negative sec square 1 minus x. So we solve it, and the final answer is 2 tan 1 minus x over x minus ln x square times sec square 1 minus x. So for the question B, it is y equal to 2x square plus 3 sin x. So we use same step. First we identify the function, which is 2x square plus 3 becomes u, and sin x become v. Then we differentiate both part. So u equal to 2x square plus 3 becomes dy becomes v 4x, and v sin x becomes cos x. Then we apply the quotient rule. So the formula for quotient rule is dy over dx equals to v times u prime minus u times v prime over v square. So we substitute it, it will become sin x times 4x minus 2x square plus 3 times cos x over sin 2x. So we solve it, and the final answer is 4x sin x minus 2x square plus 3 times cos x over sin square x. That's all. So I will pass for the next member.
Question 3. Given ln y plus cos square s cube plus e to y equal 3sy, find dy ds using implicate differentiation. Alright, first step, we need to differentiate each term with respect to the s. We need to apply the derivative operator, which is d over ds, to both sides of the equation. Alright, after that we need to divide it by 3 terms. The first term, which is ln y, and the second term, which is cos square s cube plus e to the power of the y, and the third term, which is right hand side, is 3sy. And for the first term and the second term, we need to use chain rule, and the last term, which is the third term, we need to use product rule to differentiate it. And after that, we need to assemble the component back into the equation, and after we assemble, we get the 1 over y dy ds minus 2 cos s cube plus e to the power of the y Sin s cube plus e to the power of the y 3s square plus e to the power of the y dy ds equal 3s dy ds plus 3y. After we assemble, we need to expand the bracket. After we expand, we get the 1 over y dy ds minus cs square cos s cube plus e to the power of the y sine s cube plus e to the power of the y minus 4e y cos s cube plus e to the power of the y sine s cube plus e to the power of the y dy ds equal 3s dy ds plus 3y. Alright, next step, we need to collect all the term involving dy ds. After we collect, we get now 1 over y dy ds minus 4e to the power of the y cos s cube plus e to the power of the y sine s cube plus e to the power of the y dy ds minus 3s dy ds equal 3y cs square cos s cube plus s cube plus e to the power of the y sine s cube plus e to the power of the y. And after we collect all the term involving dy ds, we need to factorize it, factorizing with dy ds. And after we factorize, we get dy ds, open the bracket, 1 over y minus 4e to the power of the y cos s cube plus e to the power of the y sine s cube plus e to the power of the y minus 3s, close the bracket, 3y plus cs square cos s cube plus e to the power of the y and sine s cube plus e to the power of the y. So it will be the dy ds equal 3y plus cs square cos s cube plus e to the power of the y sine s cube plus e to the power of the y over 1 over y minus 4e to the power of the y cos s cube plus e to the power of the y sine s cube plus e to the power of the y minus 3x. Alright.
Okay, so for the next question, which is the last question, the question 4, use linear approximation to estimate the value of 8.02 power of 2 minus 1 over 3 square root 8.02 correct to 2 decimal places. Okay, so from this question, we need to find the function first. From the question, we can determine the value of x, which is 8.02. Therefore, our function would be x, fx equal to x power of 2 minus 1 over 3 square root x. Or we can write it as x power of 2 minus x power of negative 1 over 3. Before we continue, we must take a quick look at our formula, which is Lx equal to fa plus f prime a dx. So what is a, x and dx? A is the new value, x is the initial value, which is the value that was given from the question. Meanwhile, a is the new value, which is the nearby value from x. So our x would be 8.02, since we can take it from the question. Therefore, our a would be 8, since 8.02 is closer to 8. dx is the difference between x value and a value. So 8.02 minus 8 equal to 0.02. That will be our dx value. Next, we need to substitute the a value into the function, which is f8 equal to 8 power of 2 minus 8 power of negative 1 over 3, which we will get 63.5. Next, from the same function, we need to differentiate our function, that we will get 2x plus 1 over 3 x power of negative 4 over 3. Then we need to substitute the value of a, which is 8, into this new function, which we will get 2 times 8 plus 1 over 3 times 8 power of negative 4 over 3, which we will get 16.02.08. Now into our last step, all we need to do is take all the value and put it into the formula, which is let the formula Ls equal to Fa plus F prime A ds, and we will get 63.5 plus 16.0208 times 0.02, that we will get 63.82. We will only take it into 2 decimal places. Thank you.